Hello everyone. In this video, we are going to talk about the property of x to the power of 1 over x. So let's first make this graph in Desmos. So when you look at this graph, at first it seems that the functional value approaches 0 when x goes to 0. So let's find out if that's really the case. To make calculation easier, we are going to make a natural log on both sides. And so when x goes to 0 from the right side, the denominator becomes very small. So that means this 1 over x goes to positive infinity. And in the case of ln x, when x goes to 0, the ln x goes to negative infinity. So that means the whole value approaches negative infinity. So that means if a natural log of y goes to negative infinity, that means y goes to 0. So we can say that when x goes to 0 from the right side, because y goes to 0, x to the power of 1 over x, the limit value is 0. And if we zoom out the graph, it seems that the graph goes to a certain value when x goes to positive infinity. It seems that there is a horizontal asymptote. So let's find it out. So in this case, when x goes to positive infinity, we can use the L'Hopital's rule because both the numerator and denominator goes to positive infinity. So if we differentiate, the denominator is 1 and derivative of ln x is 1 over x. So when denominator becomes infinity, the limit value is 0. So that means when ln y goes to 0, y becomes 1. So when x goes to positive infinity, this value goes to 1. And then the maximum point is about 2.718. So let's find out the exact value using differentiation. So if we take the derivative on both sides, ln y's derivative is 1 over y dy, and for the right side, we have this expression dx. So that means y prime is dy over dx is we have first derivative, and in the case of maximum value, the first derivative is 0, and because y and x squared are both positive, the 1 minus ln x is 0. So in this case, ln x is equal to 1, so x is the natural base e. That's about 2.71. So at this point, when x is equal to natural base e, this graph has the maximum value. And let's also make the graph of first derivative in Desmos. If we make this graph, so this blue curve is the graph of the first derivative. And so it also has a maximum point. And it seems that it has the local mean. And so let's just see this point using second derivative. So the second derivative is so we can write a first derivative is the product of three terms. So for the second derivative, we are going to differentiate each term and add them. And for the second term, and for the last term, and then we can substitute y prime to this expression. And then let's take out y times x to the power of minus 4. and instead of y, we can use x to the power of 1 over x. And if we simplify the parentheses, so we can add these two terms. So for the inflection points, this parenthesis should be 0. So let's see the values making the parenthesis 0. Yep. So there is an inflection point when x is 0.582. So this means at this point, the red curve shape changes from concave up to concave down. And there is another inflection point when x is 4.368. So this means the shape of the original curve changes from concave down to concave up at this point. Yep, so that's it for this video, and thanks for watching.